In Python, there are many kinds of variables. The most common are strings and numbers. Strings were great for most situations, but if you ever need to do math, you'll need to use numbers. For example, suppose you need to show the total duration of a song playlist. You need to add up the length of each song to get the total. So let's look at some code. These two lines of code create variables for the length of 2 songs. But you can see the difference between them, right? With the first variable, we're using quotation marks, but the second, we are not. Whenever we use quotation marks around a value, we are creating a string. A string is a sequence of characters like letters, symbols, or digits. So in this example, the characters we have in the string happen to be digits, but the computer doesn't treat them any differently than if they were letters. In fact, I can add text to the first variable value like this. And it won't give me an error. In fact, let's run it. Everything comes out okay. With a second variable, where we don't have quotation marks, we are creating a number. Python will store this variable differently, in a way that is designed to be used for math. I can't include any other letters or symbols, just numbers in the value assigned. If I try to add seconds here, it will cause a problem. And we can see from the red squiggly that there's something wrong with our code. And if we try to run it, we'll see the error come up, invalid syntax or syntax error. So let's fix it. The number 213 is a specific kind of number called an integer, or int for short. An integer is a whole number, including positives, negatives, and 0, but it doesn't have decimal values. So let's add that to our comment. Now we can remember that that's an integer. Let's create another number variable. If a number has a decimal value, like this, where song 3 is equal to 213.5, then Python stores it as a different kind of numeric variable called a floating point number, or float for short. Let's add a comment to that as well. This is a number, and we want to remember that it's a float. If we are directly setting variables like this, you don't really have to worry about telling Python if it's an int or a float. Python can tell the difference and will just take care of it for you, but you'll need to be aware of the difference for other situations. So let's talk for a minute about how these variables behave. If I have 2 numeric variables, either ints or floats, and I add them together, the computer will do the math. So let's create some more numeric variables and do some math. Let's use song 4 and give it a value, and song 5, and give it another value, but this time with decimal places. Last, let's do some math. We'll create a variable called playlist and use it to add song 4 to song 5. And finally, we'll print a message that the length of our song list is playlist seconds long. Now let's run that. Awesome, we can see that it printed out the playlist is 400.25 seconds. The computer did the math, and it stored the result in the variable playlist, and it worked how we expected. But what if I have 2 string variables and try to add them together? Let's go ahead and change song 4 and song 5 to be strings. I'm going to highlight the value and type the quotes, and it will put it around both of them since I highlighted it. So I'll do that on both those numbers, so I have 2 strings now. Notice that this time, even though the variables contain all digits, because we use the quotation marks around them, they are strings, not numbers. Now when you add 2 strings together in Python, it'll still work, but just kind of glues their contents together. The technical term for this is that it concatenates them. Let's run this with the debugger and see what happens. First, we'll set our breakpoint and then choose to debug our Python file. As we step through this, we'll see how each of our variables pops up in the debugger window. And if we put our mouse over the top of any one of these variables, it will tell us what kind of variable it is. Song2 is an int, song1 is a string, and we can see that song3 is a float, and then song4, song5, and playlist are all strings. And after we run the next line, playlist will have the concatenated strings. And after we ran the last line, playlist concatenated the two strings, because when we have a plus between two strings, it concatenates. So let's finish running and see our output. There's our print. The playlist is 150250.25 seconds. Little strange, but that's how concatenating strings works. But what if one was a string and the other was a number? Well, let's take off the quotes and see what happens if one remains a string and one is a number. This time, we got an error. You cannot mix strings and numbers in a math operation. Math requires all numbers, but you can explicitly tell Python to treat a variable like a number or a string. For example, if we want to tell it to treat song5 like a string, we can do that with str around it. So in our playlist equation, we're going to turn song5 into a string temporarily. I'm going to highlight it. Whoops. I'm just going to retype it. String song5. So we put string in front of song5 to tell it to treat song5 like a string. Now if we run that, we won't get an error, but it will concatenate the two strings, just like it did before. But we can also treat song4 like an int and leave song5 alone. This time, I'll highlight song4, hit the parentheses, and it will put it around the whole word, and add int to tell it to treat that song4 variable like an integer. Now when I run it, it did the math. We've told Python to treat song4 as an integer and add it to song5. No errors. Now, the important thing to remember here is that when you use the plus sign operator, both variables need to be the same type. If you want to do math, they need to be numbers. If you just want to combine or glue the values together, they need to be strings. There are more data types you can learn about and use, and it might seem a little overwhelming at first, but with a little bit of practice, you'll get comfortable with them. Play around with strings and numbers and other operators to see if there are more interesting behaviors to discover.